Hello, everyone. Our next talk is going to be next steps for HA in Debian. Our speaker is going to be Lucas Kanashiro, who is a software engineer from Canonical and also a Debian developer. So, Lucas, the stage is yours now.
Samuel. Right, so as Samuel said, today I'll talk about some next steps that I have at least in my mind for Debian regarding HA, which stands for high availability. Here I will focus more on Corosync Pacemaker cluster agents, not the other part of the stack, so the main focus will be those agents. Okay, so to start, just a quick introduction. So AJ is basically, this is from Wikipedia, so characteristics of the system which aims to ensure in a grid level of operation performance, usually uptime, for higher than a normal period. So you don't want your service to get down. You can use a cluster in case one node fails or your software fails. You can move that service to another one, and then your service will keep running even after a failure. So to do that, we can use Corosync Pacemaker cluster. There is what we call cluster lab stack, which Corosync and Pacemaker are those are piece of softwares that are part of this stack, and this cluster lab stack has enabling detection and recovery of machines application level failures in cluster. So this has been used mostly for enterprises, so they don't want their service to get down at any time. So it supports deployment of 2 nodes, a cluster with 2 nodes up to 32 nodes with active configuration. You can monitor your service, even detect failures in hardware or in software, and you can also recover from those failures using some algorithms that can quickly detect where is the best place to run your service, in which node in this cluster is the best place to run it. And of course, you can run HA without clusters, but this stack, it will avoid headaches for those sysadmins, because it solves a bunch of problems that you would have if you try to manage all of this by yourself. So why use clusters? Those clusters, the awareness of other applications in this stack, so each piece of this stack knows what the other pieces are doing, so that will help a lot. There is a sharing quorum algorithm to calculate this quorum. So when the cluster is created, that it means that you have at least the minimum to make your cluster functional. You will have data integrity through fencing. So when you have a malfunctioning node, there is this mechanism called fencing, or STONIF, which stands for shooting the head. So you kill that node if something's not working there. You just turn it off or disconnect from the network or do something like that to avoid any kind of data corruption, for instance. And there is also automated recovery of those instances. So when nodes get down, it will automatically recover that node, and it will get back again and connect it to the cluster, and we will be able to use it again in our cluster. So then there are a bunch of components. The ones that I'm most interested here are called resource agents and fence agents. Resource agents is a set of scripts that are used to manage those services. Like you can imagine a database or or something like Apache. So there's a set of scripts that those scripts knows how to move those services among all the cluster nodes, or turn the service off, on, and so on. And the fence agent is another set of scripts which contains scripts to fence those nodes. For instance, disconnect from the network, or even turn off the machine in some way. So those are the things that I will be focused on. There are other important pieces like libqb, which is a we use it for core service like logging, IPC, and so on. And of course, the Corosync and Pacemaker itself that manage membership, messaging, quorum, and all of those things. But we'll be focused more on those components. So the idea of this presentation is not to tell you how this works. I think most of you already know. But I want to present the current status of those agents in some distributions that I've been investigating and show you what I've been doing in Ubuntu to try to improve the current status and see if we could bring some of those changes into Debian so we could collaborate and try to improve this ecosystem. So agents maintenance, the maintenance of those agents in Debian, how that happens. Nowadays, resource agents and face agents, each of them they have its own source package, and the source package provide a single binary package, and that's not ideal because we don't have all the needed runtime dependencies in those binaries. For instance, you can install a script to manage a specific resource, and when you execute that, you might need to install something manually. That's what happened because we are installing all those agents in a single binary. So you can imagine if you just want to manage a Postgres instance in your cluster, for instance, you will be installing a bunch of other things like Apache and other stuff in your system. And as a sysadmin, usually you don't want that. You want to keep it minimal. And at least Debian users, when you install something through apt, grabbing the package from the Debian archive, usually you expect to have all the needed runtime dependencies also set. And that's not the case nowadays. So as I mentioned here, users need to install agents that they do not use in their systems, which is not great. And what has been done in Fedora, for instance, they also have each of those resource and defense agents. They are separate source packages, but each of them provide multiple binary packages, basically one per agent. So you have one binary package. You would have one for Postgres, one for Apache, one for LXC, whatever you want. So you can install just what you need and not a bunch of random scripts that you will not use. And there you will get all the needed runtime dependencies. For instance, I've been playing with the LVM resource agents. And I needed to install LVM things manually to make it work in Debian. In Fedora, you don't need that because everything's already there. And I don't need to pollute my system with a bunch of fixes that I don't need in the end. So what I've been doing in Ubuntu to improve this current situation. Of course, Ubuntu is based on Debian, so initially we have the same thing that we have in Debian, but I've been applying some Ubuntu-specific changes that I want to present to you. So now, each of those source packages, they are providing two binary packages. In Ubuntu, it's a bit different because we have this main and universe sections. So main, we fully support. Universe is more community-oriented. And I did split in those two binary packages because in one of them we have what we've been calling curated agents. Those curated agents, we are doing QA on them, and we make sure that they are working because this is a set of scripts, mostly shell scripts, and some of them sometimes they don't work very well nowadays because they are too old or something like that. So I've been testing all of them. I make sure that they are working. I'm adding all the needed dependencies to those curated agents. And then I have this other binary package which contains the remaining agents that I didn't test them yet, but I still want to. But I can guarantee that it works because I didn't test. Like we have in Debian. It's like a single binary package with a bunch of scripts with no runtime dependencies, and the user will need to sort all of those things by themselves. And to do this QA, we have this. It's not that good, the image, but we have this GitHub repository and canonical/server test scripts where I've been writing those automated tests. So I'm using QEMU to set up a 3-node cluster for all of them. I do configure a Pacemaker, Corosync Pacemaker cluster, and I'm using shell script to set up each of those resource inference agents. And I'm using SH unit 2 to write some automated tests for that. So I try to cause a failure, to force a failure, and see if the resource is moving to one node to another. I try to fence a node to see if things are moving to the right places and so on. So I'm making sure that the script is usable and the binary is providing all the needed runtime dependencies. If you are interested, we can chat after the talk, and I can present if someone is interested on those scripts. My idea here is basically I want to bring this to Debian because I have those scripts, and I did set up a bunch of Jenkins job in the Ubuntu infrastructure, one for each agent and for each release. So I've been testing those agents since the last Ubuntu LTS release, and I think this would be a great idea to do the same also in Debian. So I know that we have a Jenkins instance in Debian, and we could try to reuse the code. Of course, it would require some adaptations because there is some Ubuntu-specific changes there, but I think it wouldn't be that hard, and I think we could make the same in Debian and improve the quality of our agents there. So that's my main proposal here, and I don't think the split that I did might be a good idea in Debian because we don't have this concept of man and universe. But I do think that we should try to, at some point, reach the same state that we do have in Fedora, which is basically provide a single binary package per agent with everything that we need. And so any sysadmin can install whatever agent you want, and not a bunch of them by the unique binary package that we provide nowadays. So I think that's something that I would like to suggest to our Debian maintainers. I think the maintainer of the resource interface agents, I think he's not here. I tried to ping him. I sent an email to him, but I want to raise the discussion and see if we can move forward with that. So with those changes, users install a set of created agents, and not all of them. And they know that this works, and basically that's what I already mentioned. You don't need to pollute your system with all this stuff, and that's basically my proposal. I don't know if anyone is into that and have any suggestion or question about this work, but I would like to push those changes to Debian, and let's see how we can do that together. Is it working well? Okay.
Okay. So I think that the test framework you made should be applicable as is, basically, right? So
yeah.
it just requires manual installation of more packages, maybe. Mm-hmm. You mean the dependencies which are not included in the resource agent packages. So that's perfectly fine, I think. If we've got a Debian Jenkins, which I don't know of, then go on.
Yeah.
Good idea.
So yeah.
About the resource agent packages, there are at least two at the moment, as far as I know. There is one for Pacemaker-specific resource agents, and there is another for whatever is included in the upstream resource agents package or project.
Yeah.
Is that about right?
Yeah, I've been I've been working only with those resource agents. This project is maintained by RedHat upstream.
Yes.
We also have cluster glue, which also contains some set of scripts that could be used in this context. So when I get this ready and they state that I think that it's okay for our users, I would like to focus on those other pieces of the stack. Initially, I think this is a great start and will improve the user experience in general. So that's why I'm trying to focus on that.
Great. So I think the current situation is evolved because we've got a single package for all the resource agents, and if you need to manage an Apache resource, for example, you install the resource agents package, which includes the Apache resource agent and the MySQL resource agent and whatnot. You don't want to install MySQL and all the dependencies which all those resource agents require. Mm-hmm. So that's unfeasible.
Yeah, that's true. That's why we need to split in multiple binary packages.
Yes, and we have to strike a good balance here. Whether we need a separate package of all individual resource agents, or rather, the resource agents should be included in the resource packages themselves. I mean, the Apache resource agent should be included in the Apache package. The MySQL resource agent should be included in the MySQL package, maybe. So the design space is a bit wider and not very obvious what the best solution is.
Yeah, I agree with you. I've seen this kind of problem with other stuff like app armor profiles, because they are shipped in a single package. It could be shipped, each of those profiles could be shipped in those specific packages.
Basically the same problem, and we don't want to have too many packages, because that overloads the archive.
Yeah. But I think it will be hard to change this, at least at the moment, to do something like that. So I think for now, in the medium term, I think we should try to reach this goal, which is a split of those agents in separate binary packages, and test them. I think it will be good enough, at least, because we will at least match what upstream is doing, which is RedHat, and we have the same in Fedora. It's basically the same thing, RedHat, Linux, and Fedora. So we will at least match them. So we would provide a similar experience for the sysadmins maintains those clusters.
Consistency is good, for sure. And would it mean that we had to install Apache and MySQL and everything if we want to use even one of the curated resource agents?
Yeah, for now.
Because that may not fly.
Yeah, for now, yes. That's why I think this is not the best solution. I'm trying to improve, but this is not ideal, because I think in this curated set of agents, I do have 10 or 12 agents only. So that's okay. But I do see that this is not ideal. But I think at least I improve it, considering, if you consider the runtime dependencies. So I think that's already a good thing. But of course, I want to reach the state that we don't need to do that, to install all of those things that you don't want. So yeah, I think we have 1 minute, so almost over. I don't know if someone wants to.
Any other questions?
Nice.
All right, so thank you very much for your talk, Kanashiro. Let's give a round of applause for our speaker.
Thank you.